right, first one here, radicals. All right, any radical equations, you got to check. All right, and we'll go over the checking process when we hit these problems up today. Next one, absolute value. Okay, if you're solving with an absolute value, you have to check your answers at the end to see if it works or not. Next up, log equations. Anything that starts out with a log, you have to check. Not you use the log like we did yesterday in the word problems if it starts out with a log. All right, and you have to solve for x in the log. All right, so make sure you know what I'm talking about. I'm not talking about using a log. I'm talking about the actual starting equation starts out with a log. All right, and I think those are the only three that you got to check for me. Okay, those are the only three that you have to check at the end. All right, let's get right into it. Ready? We're doing evens today together, so let's look at number 2. Let me get my answer key and my numbers ready. It's been a while. There it is. Look at these mugs. There we go. All right, let's do this. I'll try to call on all different people here, so it's just not the same people. All right, here we go. I got up to 14. Got it. Ooh, here we go. Harper up first here. X cubed minus 49x equals 0. Got to solve it. First move. GCF. Darn right. GCF. Take out n. X, yep. What are you left with? X squared minus 49. Now, just let me, before Harper continues, little tidbit, keep in mind on Friday. When you're solving by factoring, highest exponent number of solutions, right? Highest exponent number of solutions I should have. So keep that in mind if you're solving it by factoring. So keep going here, Harper. I got X, and then what's the deal in the parentheses?
X minus 7, X plus 7.
There you go. Now I start to see where my 3 answers are going to be. I definitely see 2 of them. X equals positive 7, X equals negative 7, and Harper, where's the other one come from? Set your GCF equal to 0, if it's a variable. All right, if I just take out a 2, you don't need to set it equal to 0. But if it's a variable you take out as a GCF, that also needs to be set equal to 0. So there are our three answers. Questions there? Make sure it's set. I didn't ask Harper this because it was already done, but make sure it's set equal to 0 before you start. All right, number 4. What are the zeros? Solutions, answers. So automatically take that f of x and replace it with a 0. 3x squared minus 3x minus 6. Interested what you guys are going to do here. Ooh, Marnie, you're up here. What do you want to do?
Take out 3.
Thank you. Thank you. Because some of you guys are going to start doing 3 times negative 6 and make your life difficult. Take out the GCF first. Because when you do, life is real easy now. What's left, Mari?
X squared minus x minus 2.
Good. Now, this is what I was just talking about in Harper's example. Notice we took out a 3. I'm not setting that equal to 0 at the end. All right, because 3 doesn't equal 0. All right, so don't worry about setting the GCF. Plus, I know I should have 2 answers at the end. Highest exponent's 2. Keep going, Marty. What do you want inside here? 2 numbers that multiply to negative 2, but add to negative 1.
Negative 1 and negative 2.
Negative 1 and negative 2. That multiplies to 2.
Wait.
You had both negatives, what you told me. And that multiplies to a positive, but I need a negative 2.
Oh. 2 and negative 1? I don't know what I did. I got it right.
Oh, did you?
Yeah.
All right, first let's start. I agree with the 2 and the 1.
Okay.
It's got to be the only thing. Now make them add to negative 1. Right, make them add to a negative 1.
Oh, negative 2 and 1.
All right, there we go. All right. Now, before I move on, I just wrote a couple different types of problems where you have to check. That doesn't mean you can't check here, right? You can go to equations on your calculator, type in 0 equals 3x squared minus 3x minus 6, and make sure you get those 2. You just won't reject them here, right? None of these will get rejected, but you can certainly check if you have the right answer. Don't try to fudge it either. I know I recommended that for the Regents, but I'll know if you fudge it or not. All right, you can't get to the final answer in your calculator, so you just write some hot garbage in there. Not here, not here. All right, thanks, Marty. Moving on, number 6. What do we got here? Oh boy. Ooh, all right. Here we go. Here we go. All right, ready to roll? All right, find the zeros. So 0 equals x minus 3 squared minus 49. I have a feeling what many of you want to do, but you don't have to here. What do you want to do?
I was gonna do the x on it, like the
Yeah, you can. That not, you want to go x minus 3 and x minus 3 double distribute. That's fine. You can. All right, I'm going to shorten this process though. Get this by itself. Get the squared by itself. No. Just get this by itself for me. So move this over.
Oh, okay.
Go ahead.
So add 4.
Yeah, add 49. And if you guys don't feel comfortable doing this, do it what I just said. Double distribute over here. But watch what we can do here. 49 equals.
X minus 3 squared.
Yep. And now how do I get rid of that squared?
Multiply.
What? Multiply. How do you get rid of the squared here?
Oh, flip it. So 1 over 2.
Okay, you could do that. Raise it to its reciprocal. Take the square root.
Oh, yeah.
All right. But no. If you wanted to raise it to the 1/2, that's fine too. It would have worked. The only problem I have with doing this, it's a lot shorter than double distributing. The only issue I have is with this step coming up. Because you're going to do that. You're just going to write x equals 7. And it does. But hey, think about it. I do that. How many answers am I going to have? 1. X equals 10. But how many answers should I have? 2. So what did I do wrong then? It should be plus or minus 7. Yes. Okay. So if you're going to do that method and you take the square root of any number, make sure you're left with the positive version and the negative version. Okay. Because you got to get 2. And then I was only going to get 1 that way. All right. Finish this off here. Add 3 over. I get x equal to 10. And then add 3 over here. I'm going to get x equal to
Negative 10.
add 3 over.
Oh. Negative 4.
Okay. There we go. And some of you may not like that, and that's fine. That's fine. Go ahead, double distribute. And then factor it at the end. Fine. You're still going to get 10 to negative 4. Any questions there? All right, 8. Whoa, look at this thing. 3 answers we should get out here? 3 answers, huh? Whew. Oh boy, Kate, here we go. You got this. What do you want to do here? Let me.
I don't remember what it's called, but you can like grouping.
No GCF. 4 terms. Yep, we're going to group. All right, not off the hook yet. Show us how to group here. What do you want to take out of the first one?
X squared.
Okay, I agree. What's left?
2x minus 3.
All right, you better be left with the 2x minus 3 here. And it doesn't look like it.
And negative 1.
Oh, yeah, I gotta need the opposite. Everyone's good so far. I keep flying through these like everybody is, but we're good. All right, what's left in the parentheses, Kate?
X squared minus 1, 2x minus 3.
Why did I put a plus 3 there? What's that? All right, I like it. And anything else you want to keep doing?
X squared minus 1.
Good. Perfect squares. So what do you got?
X plus 1, x minus 1.
All right, now I definitely see where I'm going to get 3 answers from. When you're ready, Kate, let me know those 3. All right, when you're ready.
X equals negative 1, x equals 1, and
There you go. 1, 2, 3 answers. Good job. Anybody there? Grouping? Might be a method, right? Might be a method you have to do. Oh, wow. All right, here we go. 10. Grant.
10.
10.
I took out a GCF before.
Good job. Everyone would have probably hit up difference of perfect squares. Got to take out that GCF first. Oh, boy. There we go. All right, what's the GCF, Grant?
I did 4, then it comes out to x squared minus 25 equals 0. And then x plus 5, x minus 5.
Good. I don't need to worry about the 4 at the end, right? Because it doesn't have a variable attached, so don't worry about it at the end. Yep. Plus, oh, you got it off with an easy one, huh?
And then x equals 5 and negative 5.
That was a quick one, huh? Anything? All right, we're done with the factoring now, even though we got the odds there that have some factoring. All right, 12. Now we're up to absolute value, so we got to remind ourselves to check. I'll work on how to check here in a second. All right, first up here. Ooh, going deep. Richie, let's roll. I won't say anything. Tell me what you think you should be doing first here. Thank you. Absolute value. It's got to get by itself before you do anything. So absolute value of 2a equals 20. Usually there's a little more in that absolute value, but it is what it is.
And set it equal to 28.
Okay, all right. So he's making two equations. So once I get the absolute value alone, the first equation is just drop the absolute values. 2a equals 20. And the second equation, and again, this is the way Richie does it, is all right, keep what's in the absolute value, but change everything on the opposite side. Some of you may change everything in the absolute value and keep the other side. It's your call. Just darn it, make sure you know what you're doing by Friday. And that is it. Yep. So a equals 10. A equals negative 10. Maybe, right? Maybe. These are ones you got to check. All right. So I go to my calculator. I'll check it with you. I go to equations. Remember the absolute value. Where can I find that beast? Toolbox. So absolute value 2x. I don't want to put an a there. Plus 4 equal to 24. Solve it. Negative 10 to 10. Oh yeah, I think I'll keep that because that's that's what I think the answer is. And yep, there you go. So I'm going to keep both answers. If only one shows up, I got to reject the other. All right, I'm going to do that to you. All right, make sure you're checking and not being lazy on me. All right, decent job there, Richie. Oh, whoa, how about 14? Something different now. Whew, here we go. Emma, you're going to be up for this one. Before you start, though, I want everybody to notice number 14 has, yes, a variable in both exponents on both sides. This is not a log problem. All right, this is not a log problem. If the exponents are on both sides of the equal sign, it's not a log problem. Everyone good? All right, maybe if I just had the x on one side and not the other, but if they're on both sides of the equal sign, it is not. It's going to be a change of base, Emma, all right? 2 doesn't get any smaller. But I got to change 8 into a base of 2. So what do I need to raise that one to, Emma? 2 to the third. Again, that just replaces the 8. You still have to write in raised to the 5 minus x. All I did was replace the 8 with 2 to the third. All right, let's keep going over there. I got 2 to the 2x. What's the rule here with the 3 and the 5 minus x? What do I have to do? Yep. So once I distribute, 15 minus 3x. Once the bases are the same, what can I do with the exponents, Emma? There you go. But they have to be, the bases have to be the same. So I got 2x equals 15 minus 3x, and then solve away. When you have it, Emma, let me know. X equals positive 3, yes. Yep. And this is not one I have to check. So be careful here. I know everyone sees the variable in the exponent, so you're automatically thinking logs, but if it's on both sides of the equal, it's not logs, it's change of base. Change of base. All right, good work there, Emma, good work. Ooh, I like 16. 16 can be done a couple ways here. And whoever has it, I'll let you choose there. 16 can be done a couple ways. Whew. Max, you got 2 different ways we could do this. Your call.
I did change the base.
Okay, you could change the base, and notice where I only have the exponent on one side, so you could do logs here as well. Bring the 3x plus 5 down, log both sides, you could. It's Max's show though, so we're going to change a base. What are your, did you change 4 at all, or keep it? That's fine. You could also change the base to 2 to make it smaller, but you could keep it 4 here. And if Max is going to keep that a base of 4, how are you going to change 16 into a base of 4? 4 squared. There you go. Love this problem. You could do logs. You could change the base to 2s, or like Max did here, keep it to 4s. Your call, though. Your call. Great problem. And what do you got for the value of x there, Max?
Negative.
-1 it is. Yeah. Anybody? So you do what you're comfortable with, right? Do what you're comfortable. If you're comfortable doing logs, do logs, guys. You want to change it to a base of 2 instead of 4? Go ahead. Change them both. All right, 18 now. Who's up here? Marnie already went. Beautiful job. Already went in the back there with 2 chains. Good. Ariana already went. We'll find somebody here. Kate already went. Great. Oh, there it is, Paige. What's going on? You ready to roll?
Yeah, it's the only one I haven't done actually.
Whoa! Lucky me. Generator knows.
Do you just do
Could you do that?
I don't know.
No, wait.
I don't remember.
Not with the not with the 2 to the x. All right, Ray. Where's the variable? It's only on one
wait.
side. This wouldn't be I wouldn't try to change the base.
I just don't remember.
If you were thinking changing the base, because I don't know, 2 to the something gives me 3/16. That's the problem. Right? I'm never going to find that out.
Yeah.
So I would take your x, bring it down.
Oh, it is a log.
It is, yeah.
Okay.
Right? As the variable is in the exponent, it is. So what's that going to look like? X
Log 2.
log 2.
Log 360.
There it is. Everyone all right on how this is a log problem? I can't change the base because, hey, if I change the base, I'm going to have to try to figure out 2 raised to what gives me 3/16. I'm not even too sure of that. I have no idea. I'm not even going to play around with that. All right, what do you want to do on both sides to get x by itself?
Divide by log 2.
There you go. And the directions are there because it's not going to be a whole number.
Negative 2.42.
Negative 2.42. I'll trust you. I don't have my key with me there, but I'll trust you. Anything? Logs? Using logs? All right. Again, this is one I was talking about earlier. I use logs, but this isn't going to be a I must check problem. All right. It's got to start out with a log to be a must check one. So you can check it to see if it's right, but it's not going to get rejected. Ooh, 20. This is where kids always have a heart attack on the test. They forget how to do these. There we go, Drew. Oh, yeah. Let's go, boss. First, before I'm going to help Drew out here.
No, I got it. I got it. No, I don't got it.
All right. Okay. We don't solve log equations. You can't solve a log equation. This isn't no solution either. I don't know how to solve a log equation, but I do know how to solve exponentials. So we change it into an exponential. Here we go, Drew. What's the base here?
5x minus 1.
Ready? 5x minus 1 raised to what's on the other side?
1/3.
Okay, now be careful how we do this. I'm not doing this because I just raised the 1 to the 1/3. Whole thing raised to the 1/3 equal to what's left?
Log of 4.
No log anymore. I don't want. That's why I'm trying to change it. No log. You're not out of the woods yet. Jeez, listen. You got two types of problems in one. So everyone all right with the transformation? Got to transform it. All right, hey, Drew, base, exponent all by itself. So don't be moving anything over on me. Base and exponent are by itself. How do I get rid of the 1/3?
You gotta flip it. Flip the fraction.
And raise it to the what?
There.
There you go. Raise it to the 3rd, and also what else has to be raised to the 3rd? What's your deal? Is this like, I've never seen this before? All right. You want to get rid of an exponent. You raise it to its reciprocal. All right, Drew, what's left on the left side?
5x minus 1.
Yeah. You tell me 12, get out of here.
64.
Thank you. And I think you can handle it from here. So when you're ready, know the final answer.
13.
13 it is. And it's got to get checked. Why? I start with a log. All right. Do we know how to plug this in? Equations? We're comfortable doing this into equations? Or do we want to review that?
We're good.
Okay. Kate speaks. We're good. I think this is the toughest one we've done so far today. Not only do we have to change it into exponential, but everyone always forgets this part here. Raise it to the reciprocal. Forgets it. Thanks, Drew. We good? Don't forget how to do this on Friday. Like obviously you forgot about the sunscreen over break. But, all right. I was just waiting for that one. I was waiting for that one. Yeah. It's been a couple days. I've been saving it up. All right. 22. We're almost done here. Grant already went. We're getting down to the nitty gritty here. Only a couple people left. Stella, let's go. All right, 22. First move.
Move the 4x and 20.
Good. Get it equal to 0. How many answers are we going to have here, hopefully?
3.
Good. Get it equal to 0. All right, your show now. Group it. Yep, no GCF. What do you want to take out of the first one?
X squared.
Yep. What's left?
Then you'll have to x plus 5.
All right, give me an x plus 5 left in the next one.
Negative 4.
You all right? Speak much? All right. Take out the 4. What's left?
X plus 5.
Everyone gets a piece in here. Don't worry. Everyone gets a piece. All right, what's left in your first parenthesis?
X squared minus 4. X plus 5.
Yep. I only see 2 parentheses, but I was hoping for 3 because we said 3 answers, right?
Difference of
Yep. Go ahead, finish it.
X minus 2, x plus 12.
All right. 3 answers.
2, negative 2, negative 5.
There you go. Questions? Who gets the word problem? 24. Who's going to get the word problem? We're down to the nitty gritty here. Who do I got left? Ethan and Gabby? He already went. He did the absolute value one. Okay, here we go. It's going to take forever to get one of your two numbers. What am I looking for here? 8 and 6. All right. I should just put, oh, there we go. Don't need it. Ready to go, Ethan?
Yeah.
All right. Wow, 80 views as soon as it's posted, huh? I gave you a little equation there, Ethan. T is the time measured in days. How many days is it going to take till 2,500 people? That's light work, isn't it, nowadays? Viewers on YouTube, light work, 2,500. Okay. All right, sorry, I have a pop culture discussion. All right, where is that 2,500 going to go there, Ethan?
Sub it in for Y.
Yep, sub it in for Y, good. And we're solving for T. T looks like it's in the exponent there, Ethan, so I'd like to say logs are going to be involved, but I know you better, so I know what's going to be involved instead here. But can't do anything until it's by itself. Divide by 80. Yep, don't do anything until the base and exponent are by itself. E to the 0.2t. What's that over there going to be? 31.25. What?
I did a fraction.
All right, I'm just going to.
Same thing.
Is it all right if I leave it as 31.25? Thank you. All right, I definitely know what crowd you roll with on the next step, but if anybody wants to log, you can. That's fine. All right, take 0.2t down, log the E, and log the 31.25. But I know what camp you fall into, which would be to do what on both sides? Natural log it. Yep, you can natural log both sides as long as the base is an E. All right, so I take the ln on one side, ln on the other, which cancels out the E. And all you're left with is that exponent. 0.2t equals ln of 31.25, whatever that long decimal is. And then how are you going to finish it? Well, actually, everyone's going to finish it the same way, which is what? Divided by? Yep. How many days till we hit?
I got 17.2.
Yep. I feel like earlier in the year we've had this discussion on YouTube hits. No? Or is that a different class?
No, it was like number of texts sent per day.
Oh, yeah.
I remember that one. I feel like there was a YouTube and people were busting out their YouTube numbers about how many views a video had of theirs. Wasn't there something over here?
No.
I think there was. Yeah. And 26. You ready to go, Gabby? And there was one. This is nothing. This is nothing. All right, there's my equation. Find x if the price is 99. So where are we plugging the 99 in?
P,
Yep.
for P.
Yep. All right, you got some work to do here to get x by itself. Some serious work. This is about it. This is as tough as it comes, I think, because you got to do everything here. First move.
Subtract 400.
Yep. What am I going to get there?
I got negative 301.
Yep. I get a little nervous here. Don't drop the negative. All right, it's negative 0.06. All right, still got work to do. What's your next move?
Divide the negative 0.6.
Good. Yep. Divide both sides by negative 0.06. And I noticed yesterday as I was correcting some of your word problems, type it in carefully. Type it in carefully. A lot of you guys added an extra 0 or forgot a 0 when you were typing it in. What's up, Emma?
If it doesn't give us rounding, what should we round to?
I will give you rounding. Don't worry. We're going to round to the nearest whole number here at the end, but I will give you rounding on all 10 of them. And if it doesn't have rounding, then on Friday, it probably should be a whole number then. Okay? Let's see, Gabby. Whoa, geez. Look at that number, huh?
Can I keep it as a fraction?
You do whatever floats your boat. This is what I have on my key, so I'm going to write it out. All right, I think I know what camp you fall into here. So what do you want to do?
I'm a log.
You're a logger, yeah, which is fine.
So
Just make sure you log both sides. It's 5 of them. All right, if you are a logger, then how do I get, where's my variable? X, sorry. Okay, what do you want to do next to get X by itself?
divide by 0.003 log e.
Oh, you're an all at once one. Good. We could do it separately if we wanted to, though, right? And make it into 2 steps. And again, we'll go nearest whole number here. Nearest whole number.
Is 2,840.
Good. Okay, I'm not going to stop you from doing work outside of class, but we are going to have time to do the odds tomorrow. Okay?